Oh yeah, right. I thought what I'd do is do a new video for virtual population analysis. And I thought we start off with a simple example. It's given in the Jennings textbook that there's a link on Canvas for. So with virtual population analysis, what we do is we use catch data to work out what the population must be to support that catch. So if you've caught 80 fish, if you caught 100% of the fish, you catch 80. If you have a catch of 80 and you've only caught half of those, half of the population, there would be 160 fish in the population. Okay, if you have a catch of 80 and you've caught a quarter of the fish, you'd have 320 fish in the population. Okay, so catch is a proportion of the total population, which is determined in equations using F, which is fishing mortality. So fishing mortality is basically catch. And you can kind of use the two terms interchangeably. F is an exponential and catch is the number. So we've got another couple of numbers here that we're going to plug in. So one is natural mortality. And you know that we've decided that natural mortality is basically 0.2. So we're just going to make that assumption. Okay, so we'll just plug those numbers in. So 0.2 is natural mortality, and we have to make up a mortality for fishing mortality to make the equations work. You'll see why in a minute. So we can assume that these are 3-year-old fish here. So we've got fish aged 1, 2, and 3. If the fish only live for 3 years, because we've only got 3 years worth of data, then you can assume that the mortality of 3-year-old fish in a fish like I was going to say herring, but herring live a bit longer than that. Maybe sand eels. Maybe sand eels only live for 3 years. The terminal mortality, the mortality of those fish in the final year, is going to be high. Okay, so it's not going to be 0.2. It'll be higher than that. So we're going to make that 0.6. Right, so these are made up numbers. We've kind of guesstimated them for now. Okay, so I'll just highlight that to remind us that these are made up. Oops, that's not what I want to do. I want to highlight this. There we go. That one. Okay. The other number we've got is Z. Now Z is the combination of fishing mortality and natural mortality. So we just add them together. So that equals 0.6 plus 0.2. Right? My spreadsheet's doing something weird here, so I'm just going to say calculate now. It's putting these lines, I don't know why, it's putting these lines in here. Anyway, so that's 0.8. And now what we need to do is work out how big the population must have been in order to have a catch of 80 with a fishing mortality of 0.6 and a mortality of 0.2. Okay, so that's an equation here. Let me just show you. This sheet is on Canvas now. So we're going to use this equation here. So we're going to work out how many fish there must have been in the population to support a catch based on our fishing mortalities. Okay, so this is the equation you use when you don't know what the population is. So we just have to slot that equation into R. So we're not going to put this number in. We're going to work out what that number is based on catch and these values here. So let me just put that over here. I think I can copy the equation. I'll copy the equation and put it here so we can keep it, so we can work out what we're doing. So we're basically just going to plug that equation in here. Okay, so you only do this with the last age class of the fish though. So equals to start it, and we've got catch there. It's the top line, so we just click on there. So that's the C value there, and then we've got a divide, and it's all of these terms here. So I'm going to put a bracket in at the beginning for all of the terms, and then I'm going to put another bracket in to just cover this first term here, which is fishing mortality divided by total mortality, okay, which is Z, so it's F over Z. So that's the first thing, and then we multiply that by 1 minus the AXP of minus Z, okay? And then just to close the brackets completely, watch when I do this, you'll see the brackets blink the same color, okay? So I've closed those brackets there, then I put another one in, and they blink here. So you see that's, so now that term is completely kind of on its own. We're not doing anything silly like dividing catch by just that bit, or I don't know what else you could go wrong there, but we're calculating all of that first and then dividing catch by that, okay? So this is what brackets do. Brackets can sometimes be thought of as and then. So this is divide f by z and then multiply it by this factor here. So this means take e to the minus z from 1 and then multiply it by this. Okay, so I've got two. So it's basically a way of making sure you do your. It's BODMAS again. You know, so it's a way of making sure you do your calculations in the right order. Okay, so now hopefully when I press this, I'll get a sensible answer. So that thing's turning up. I don't know what that is, but you can see it's 193.7, which is what I was expecting. So if you look in the Jennings book, you'll see that that's what he ends up with. So 193 fish is the number of fish you must have in the population to support a catch of 80 if you've got a fishing mortality of 0.6 and a natural mortality of 0.2. Okay, so we've done that bit. Now, let's just slot that in there. We'll go to the next bit. So this is just I was trying to make it simple by splitting these things up, you know. So we basically got 193 supports a catch of 80, and we now have to put in. So now that we know the catch, we know the population, and we've estimated. I know these numbers are made up, so these are still made up numbers. Made up numbers. Some people really struggle with the fact that we have to use made up numbers. So I'm just checking my phone. I'm picking my wife up later on. So these are both made up numbers. But now what we want to do is to work out. So we know the catch there, we know the population there, and we've estimated the fishing mortality at 0.6. We can now work out what fishing mortality must have been in the previous year there to yield a catch of 90 and leave a population of 194 survivors. Okay, so these 194 survivors are what was left. So the previous year. So we need to know what the fishing mortality would have been in order to end up with that value. So we have to make up a figure for f, which is fishing mortality. Now it's probably going to be less than the terminal f, so we sort of make it, I don't know, let's make it 0.5. So we're just estimating that for now. Okay. So because we've made that 0.5, we now have total mortality of 0.7. Okay, so last year it was 0.6. So 0.5 plus 0.2 gives you 0.7. Right, so the next equation that we want to use to calculate for the year before is this one. Okay, so we'll work through the proof of this in class, or I might do a separate lecture on it, but I just wanted to get the spreadsheet stuff up. So this is where we work out what, we know what fishing mortality is, and we know what natural mortality is, because we've kind of estimated that. And we know what the number of fish is in the population next year. Okay, NT plus 1 is the population next year, so that's there. We know what the catch is this year. And so what we're going to do actually is, because we know what the catch is, we're going to plug in values to this equation. We know what natural mortality is. We don't actually know for sure what this value is, what the fishing mortality is. So we're going to estimate that by changing the value of f until we get a value, the catch value that's the same as this one. We want that c term to be 90. Okay, so if I go over here and I plug this equation in, so I go equals, I want to do, so it's f, which is 0.5, divided by f plus m, there, okay, and then we're going to multiply it. Let's see if I got that all isolated. Let's just make sure. So that's all isolated, so the bracket's flashing on there. And then we multiply that by the number of fish at t plus 1. Okay, so that's the number of fish, that's the previous equation we worked out, so it's times that value there, times C18. And then times exp of f plus m. And then that's minus 1. There we go. Where's my final bracket? So there we've got all the brackets explained there. Okay, so if I press return now, we've got a value of 140. I don't know. Oh, this is really annoying. Okay, so we've got a value of 140. 140 is not 90. Okay, so what we want is for that value to equal 90, and we want to get that by varying this value here, so of 0.5. So if I make that f value 0.4, you can see that drops a little bit. But of course we don't have to do that. We can do what we did previously, and we can use the goal seek function. So if I go to what if goal seek, right? Now I want to make that cell there equal 90 by changing the f value. Okay, let's try that. Okay, so we've got an f value, we've got a f value of 0.349. Okay, catch value is 90, and so that's our new estimate of f. So that's the value that we must have had if we had this number of fish surviving the population next year and this catch this year. Okay, so now we need to work out how many fish there must have been. Oops. Okay, now we need to work out how many fish there must have been this year to support that catch of 90 with these values of fishing mortality and natural mortality. Okay, so let me just scroll down again. So all these numbers appear in the right place? Yes. Right, so we're trying to work out this value now. Now the equation we want to use for that is that one. So it's this equation. Okay, so that's number of fish this year, that's this value here, that's n at t. Now it uses the number of fish next year plus the number of fish caught and natural mortality rate. Now we don't have to use f here because that's what the 90 is basically that. So if we put that in and we go n at t plus 1 times exp natural mortality divided by 2, bracket around that. We want all of that to be in one set of brackets, so put a bracket there. Right, so that's all in one set of brackets, and then that's times exp m. What's that? No, I can't get that to go in. It's in the way. So that's E31, which is that value there. So E31 divided by 2, and then press return. And now we know that we should have had, there must have been 236 fish the previous year in order to end up with 193 fish the following year and give us a catch of 90, okay, this year. Then we just go through the whole lot again and redo them, and we'd work out calculate the catch there. Okay, so I'm going to do a lecture on the proof for this, but I just wanted to go through the steps on the spreadsheet, just so if you feel like it, you can have a go. I urge you to have a go before the lecture, the session next week, and I'll put another video up. There's also a load of other VPA or things that we did in the first week here. So like I call them equations of death. So you can have a play with these as well. Okay. Right, I think that's enough for now.